Good morning, students, parents, and guardians. I am happy to be with you in this video lesson. I will be your teacher today. I am Teacher Arcel Figueroa. Students, this is our first day for the first week of our class as a grade 7 student. Please just stay at home and keep safe during this pandemic. You will continue learning using this video lesson and the printed modules with your parents and older siblings. Are you ready? Very good. Now, let's start. For this lesson, we go through with the different concepts related to sets. We will define a well-defined set, illustrate a subset, universal set, null set, cardinality of set, and analyze union, intersection, and the difference of two sets. Dear learners, please listen carefully and be attentive for the whole duration of the video because there will be questions for you to answer afterwards. Again, today our lesson is all about sets. The groups are called sets. Set may be thought as a collection of objects. We have here a set of mountains, set of books, and set of buildings. In mathematics, set is a well-defined group or collection of objects that share common characteristics. The objects contained in the set are called elements. A set can be named using capital letters like capital letter A, B, C, D, up to Z. And we use braces to group the elements of set separated by commas. If a set contains many elements, we often use three dots, called ellipses. Example 1 is a set of primary colors, or we can say set M has the elements red, yellow, and blue. Example 2 is a set of even numbers. Set E with the elements 2, 4, 6, and so on.
Example 4 is a set of letters in the word arrange. Set O equals the elements A, R, N, G, E.
Take a look at these sets. The sets given are not well defined since people will have different point of views on famous dancers, punctual students, and honest people. Teacher Giselle is a known dancer to others, but some of us may not know her at all. You will try to answer questions numbered 1, 3, and 5. You have a minute to do it. Please pause the video while working. Are you done? Now, let us check if we got it correctly. Number 1, the set of young politicians. It is not well defined because others may perceive 40 years old politician as young, but others may consider it old enough. Number 3, the set of versatile actresses. It is not well defined because we have different point of views on versatility. Number 5, the set of months containing 31 days. Yes, it is well defined because we can identify that only January, March, May, July, August, October, and December, which have 31 days. Can you determine now which set is well-defined and which is not? Will you answer now numbers 2, 4, 6? Please pause the video while answering. Try to answer what I have learned now on pages 5 to 6 of your module. Please pause the video for 5 minutes. Have you done it well? Do you still have questions? This time, we will dig deeper on the different terminologies related to sets. The universal set is a set that contains all objects under consideration. The 3 sets are examples of a universal set. Example 1 is universal set that contains the set of whole numbers. Example 2 is universal set that contains the set of all letters of the English alphabet from A to Z. And number 3 is universal set that contains the set of days of the week. Given any 2 sets, A and B, if every element in A is also an element in B, then A is a subset of B. The symbol is read as A is a subset of B. In example 1, we have set R whose elements are 1 and 2. The subsets are 1 and 2, 1, 2, and empty set or null set. In example 2, we have set O whose elements are red, blue, and yellow. Its subsets are red, blue, and yellow. Red, blue, red, yellow, blue, yellow, red, blue, yellow, and empty set or null set. What is your observation on the examples presented? Very good! Every set is a subset of itself, and empty set is a subset of every set. But look! What is an empty set? A set with no element is an empty set or null set. The symbol for empty set is empty braces or phi. Observe the examples given. Set T is a set of counting numbers between 1 and 2. Can you think of a number? Yes, there is no such number. That is why it is a null set. The second set I is a set of month with 35 days. What month is it? No such month, and so it is a null set. The third set M is a set of cars with 60 doors. Had you seen such car? None. That is why it is a null set. As you can see in the examples, There is no element that will fit the descriptions. That is why there is no element in the sets. Another term related to set is the cardinality of sets. The cardinal number of set A, denoted by n of A, is the number of elements in set A.
In example 1, set D is a set of vowels in the English alphabet. The cardinality is 5 because we have 5 vowels in the English alphabet, namely A, E, I, O, U. In example number 2, set R is a set of letters in the word difficulty. The cardinality is 8 because we will not count the repeating letters in the word difficulty. So, we have only letter D, I, F, C, U, L, T, Y.
And in the third example, set M is a set of odd numbers between 1 and 3. The cardinality is 0 since there is no odd number between 1 and 3.
Can you find the cardinality of sets A, B, and C on page 11?
Please pause the video for a minute to answer. The cardinality of set A is 7 because there are 7 days in a week, while the cardinality of the word difficulty is 8 because we will not count the repeating letters. And the cardinality of set C is 0 since it is a null set. A thumbs up for everyone! You are now ready to answer questions on pages 11 to 12. Now, we will continue exploring sets. In arithmetic, we have learned the 4 fundamental operations that help us combine numbers. In sets, we are going to learn about union and intersection of sets and the difference of two sets. Let us familiarize ourselves on the symbols and definitions of different set operations. The union of sets A and B, written as A, union of B, is the set of elements that are members of A or members of B, or members of both A and B. As you can see on the 3 examples, the union of the given sets is just the combination of the elements on the sets. We have here some examples of finding the union of sets. In number 1,
If A equals 1, 2, 3, and B is equal to 1, 2, 4, 5, 6, then A union B is 1, 2, 3, 4, 5, 6.
number 2, if A is equal to A, B, C, D, E, and B is equal to A, E, I, O, U, then A intersection of B is equal to A, B, C, D, E, I, O, U. Yes? Did you observe something? Very nice observation. If there is a similar element, it is just written once. The intersection of two sets A and B, written as A intersection of B is the set of all elements common to both sets A and B. Example, number 1. If A is equal to 1, 2, 3, and B is equal to 1, 2, 4, 5, 6, then A intersection of B is equal to 1, 2. Number 2. If A is equal to A, B, C, D, E, and B is equal to A, E, I, O, U, then A intersection of B is equal to A, E. Number 3. If A is equal to Monday, Tuesday, Wednesday, Thursday, Friday, and B is equal to Saturday, Sunday, then A intersection of B is equal to null set or empty set. As you can see on the first two examples, the elements in the intersection of sets are the elements that is present on both sets. In number 3, the intersection is a null set. Why? Yes, very good. There is no common element on the two sets. The difference of set A and B, written as A minus B, is a set of elements in A that are not in B. In finding the difference of two sets, you will just simply eliminate elements from the first set, those elements present on the second set. Example.
Number 1. If A is equal to 1, 2, 3, and B is equal to 1, 2, 4, 5, 6, then A minus B is equal to 3, while B minus A is equal to 4, 5, 6.
In example 1, A minus B is equal to 3 because 1 and 2 are elements of B, while B minus A is equal to 4, 5, 6, since 1 and 2 are also elements of A. In example 2, if A is equal to A, B, C, D, E, and B is equal to A, E, I, O, U, then A minus B is equal to B, C, D, while B minus A is equal to I, O, U.
Number 2. A minus B is equal to B, C, D. Elements A and E are omitted since they are also elements of B. Then, B minus A is equal to I, O, U, since A and E are also elements of A.
Do you follow me? Okay, let us try to answer what's more in your module, page 15. We will do together numbers 1, 4, and 7, then you will do the rest. Number 1, A intersection of C is equal to 1, 3, 5, 7, 9, since all the elements are in both sets. Number 4, B universal set of C is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is a combination of the sets. Number 7, A minus C is equal to 2, 4, 6, 8, 10. These are the elements of A that are not in C. Do you have any questions? Now you do the rest of the numbers. This time, let us have a recap on your lesson about the introduction of sets. Kindly go back to your notes and modules and let's check the things that you have learned. Number 1, set is a group or collection of objects whose members are called elements. Number 2, a null set is an empty set, a set with no element. Number 3, set is a well-defined set if you can exactly identify the elements. Number 4, the cardinality of a set is the number of elements of the set. Cardinality of sets can be described as finite or infinite. Number 5, universal set denoted as U. It is a set that includes all elements being considered in a given situation. Number 6, set C is subset of set B, written as C subset of B, also C subset of B, read as set C is a proper subset of set B. Number 7, the intersection of sets A and B is a set containing the elements that are in both A and B. Number 8, the union of A and B is a set containing the elements that are in A, or in B, or in both A and B. Number 9, the difference of set B from set A, written A minus B, is a set of elements in A but not in B. I hope this time that everything is already clear to you. I am so glad that you are cooperative in all the tasks given. Now, you are ready to do the last task, the assessment on pages 18 to 19, and the additional activities on pages 19 to 20. Happy working! After doing so, you can check your work from the answer key. God bless students and keep safe.